Hello everyone, welcome to Poesy's e-learning and certification services. This is a new video session in the Internet of Intelligent Things series. And in this session, you will learn how to build an IoT sensor node using NodeMCU and LM35 temperature sensor. LM35 is a low-cost linear temperature sensor. It comes calibrated directly in degrees Celsius. Its scale factor is 10 millivolt per degree Celsius. That means a change in the temperature by 1 degree Celsius causes change in the output voltage by 10 millivolt. It offers 0.5 degrees Celsius ensured accuracy at 25 degrees Celsius. It is rated to work in temperature range from minus 55 degrees Celsius to 150 degrees Celsius. It is low cost due to wafer level trimming. The operating voltage is from 4 volt to 30 volt. It draws very less current, lesser than 60 microampere, and its self-heating characteristic is low, only 0.08 degrees Celsius in still air. LM35 has 3 legs or leads. When you keep flat surface pointing towards you, the leftmost pin or lead is supply pin. Middle one is output voltage and rightmost one is GND or ground. To connect LM35 temperature sensor to NodeMCU development board, mount it on a breadboard in such a way that flat side of the sensor is pointing towards you. Connect leftmost pin with the help of a wire to 3.3 volt pin of NodeMCU board. Connect rightmost pin to one of the GND pin of NodeMCU board. Connect middle pin of the sensor to A0 analog input pin of NodeMCU development board. Once your connections are done, in the next step, we will write and upload a program on NodeMCU board to read temperature data and send it to laptop. Before we upload code on NodeMCU board, let me show you actual hardware circuit. I have LM35 temperature sensor mounted on breadboard. I've used 3 wires to connect it to NodeMCU board. NodeMCU board is connected to laptop using a micro USB cable. So this is our hardware setup. The code is on my screen. Let me explain it to you line by line. In the first line, we are assigning a name sensor pin to A0 pin of NodeMCU board. Next, we have declared 2 variables, TempC and S voltage. TempC to hold final temperature values, S voltage to hold a value equivalent to sensor voltage coming to ADC as input in millivolt. Inside setup function, I have called begin method to initialize serial or UART port at 9600 bits per second rate to send data to PC or laptop. Inside loop function, the first line of code is a call to analog read function to read sensor pin and assign a value representing sensor voltage coming to it to xval. In the next step, we are multiplying xval by 3100 and dividing it by 1023 to convert this value xval into S voltage. The value assigned to S voltage represent sensor's output voltage coming to A0 pin in millivolts. I will explain the logic behind these calculations in a separate video. In the next step, we are dividing S voltage value by 10. This is conversion factor or scale factor of LM35 temperature sensor. Once we have TMC, our temperature in degrees Celsius, we are finally converting it into a message and sending it to laptop. Next, I've called a delay of 2000 millisecond or 2 seconds. The set of code placed inside loop function will run repeatedly every 2 seconds. In the next step, we will go to Tools menu, Board, ESP8266 boards, and from here we are going to select NodeMCU 1.0, the development board being used by us. Next, we'll go back to Tools menu, select COM port. COM port assigned to NodeMCU on my computer is COM4. It may be different on your computer. You will have to verify it from Device Manager. Next, click on Upload to upload this code on NodeMCU board. Code has been uploaded successfully. You can ignore this message. To view temperature values coming from NodeMCU, you can use Serial Monitor utility built into Arduino IDE. To open it, click here on this button. Make sure the baud rate setting is at 9600 bits per second. Once all set, you will have temperature values displayed inside Serial Monitor window. Great. So we have successfully connected LM35 temperature sensor to NodeMCU board, uploaded a program on it, and acquired temperature sensor data. I hope you enjoyed this session. In the next session, we'll learn how to connect BHT22 to Arduino board to collect temperature as well as humidity data. So stay tuned, stay in touch, happy learning.